I started out with a Delrin plug. Just took a piece of Delrin, got a draft angle on it, rounded it, and then I put this on a parting board, and from that right there I built up a little box and I made this casting here. So it's just a high temp tool cast, so this cavity matches this part, and I poured that over the top of this. So the problem I got into, if I wanted to actually make a match die mold, if I poured this part of the casting, which would be the male part, into the female, well, it would match exactly that dimension. So technically, when it came time to make the part, there would be no room between this mold and this mold for the material. So to simulate the material thickness, I utilized tooling wax. So the tooling wax was formed down in this female mold with this little ball end forming tool, and I made this on the lathe. Just you can make them all different sizes, but this allowed me to actually form the tooling wax down in there, smooth it out, and then I brought the tooling wax up on this face here. So in effect, once the material, which was one layer of carbon fiber, wetted out with resin, was laid over the female tool, and then the male tool was smashed down over the top to create this part. So this part represents the 10 thousandths thick tooling wax that I used to form this tool. And what this is of course proof of concept, but we utilize these as push rod exit guides. So if you have a RC plane, you want a really nice little cool exit guide, you know, this is glued into the fuselage side or your wing with the servo up here, and then the push rod comes out here. So it was a perfect way to experiment with the tooling wax. So the tooling wax comes in sheets, of course. This you can get it all different thicknesses. This was bought quite a few years ago, but I'm sure they still have it. It was bought from Freeman, and Freeman has a lot of product related to the foundry and the composite industry. It's over there in Avon, Ohio, which I think is a suburb of Columbus. I'm not sure. Then they have different warehouses: Fort Worth, Wichita, Wisconsin, Alabama, and I'm not sure. That was years ago, so this still might be there. And the neat thing about this sheet wax, I don't know the exact specs. It says thermostable, so I think you could actually, it'll take a little heat, adhesive coated. So when you form it to the tool to come up with your thickness of your wax, it'll stick. So let's cut off a little piece of this here. Do a little, I'm not going to actually lay up the part, but so this wax, I guess, is 10 thousandths. Now let's say you needed 20 thousandths. So well, just use 2 layers of it. And it's sort of like a wax in a plastic. So the way I did it, of course, was the whole piece. You can start by laying it down in there and get it started. And it does stretch. I mean, And I think if you warmed it up a little bit, it would stretch even more. This is pretty cold. And the other thing is, once you get the stretch on it, you're probably looking at a little bit thinner than 10,000. So I just slowly work it into the mold. And obviously, you know, if you had something that was really complex detail, this wouldn't work. I mean, this is basically to build up a draft angle or part of the mold that you needed clearance. And I'm working this down there slowly. See if I can get a stretch on this corner here. As you can see, the tool becomes almost a necessity. The wax is giving you clearance this way. It's probably 20 thousandths. So you're just going to have to experiment with different layers of carbon and how much material you put in there. You still want it to close, but you want it to be tight when the material is in there. So that's a quick overview of this tooling wax. Let's see just how much this stuff moves under heat. You could also form it over a mail tool, I guess, if you needed to build up a thickness in that regard. You could reverse just what I did. So yeah, with a monocoat iron, you can see how it just really thinned out.